Hi and welcome back to the channel. I'm Dr. Downey, and today we're going to discuss the relation between Tren, or also known as Trenbolone or 17-beta Trenbolone, and whether or not it is linked to Alzheimer's, because if you've been around the steroid community, there's this belief that Tren contributes to Alzheimer's disease. So I will be going through the study that initially brought this claim to light, and I'll link it below. It is called 17-beta Trenbolone, an anabolic androgenic steroid as well as an environmental hormone, contributes to neurodegeneration. The reason they mention it's an environmental hormone is because it's injected in cattle. I don't know if it still is, but I know it is in the US. So they're essentially saying that if you eat meat that's been altered with this hormone, it's an environmental risk factor. So the reason it's thought Trenbolone causes Alzheimer's is through the amyloid beta hypothesis, in that Tren causes beta amyloid buildup in the brain, which results in Alzheimer's. This is the most popular or prevailing hypothesis at the moment to explain the pathogenesis of Alzheimer's disease. And it's thought that these senile plaques that you see in the brain are made up of amyloid beta 40 and amyloid beta 42. And in this study in particular, they measured amyloid beta 42 levels, and this was done in mice, I think. And the reason they chose amyloid beta 42 over 40 is that amyloid beta 42 accumulates quicker than does amyloid beta 40, but they're both thought to play a role. So just like a background on what this amyloid peptide or beta peptide is, it's essentially like this transmembranous protein commonly found in mostly in neuronal tissue, but you can also find it in non-neuronal tissue, which is why plasma amyloid beta levels aren't the most accurate, because you can find it in peripheral tissues as opposed to just central tissues. And so what happens is there is proteolysis of this protein, this APP protein, by these secretases, and they're cleavaged into by the beta secretase and gamma secretase into amyloid beta, which is thought to then be accumulate in the brain. Whereas if alpha secretase cleaves this protein, it apparently does not result in amyloid beta being produced, which is why they have created targets. I think one of the most recent drugs actually both target this secretase, both beta and gamma secretase, to prevent this accumulation. So the Trenbolone was administered, I think, over 5 doses, or it was one. It wasn't very clear, but it was done in adult rats, both male and female, and the females were pregnant. They just wanted to see if it crosses the placenta, because it is well known or documented that androgens cross the blood-brain barrier, but they just wanted to prove that again in this study. So they did varying dosages, and the highest was 5 milligrams per kg. Now this results in a few incorrect interpretations by the average steroid user. They assume that because it's 5 milligrams per kg, oh, I'm 100 kgs and I'm not, this was 5 milligrams per kg per day. And I'm not using 500 milligrams of Tren a day, because that would be ridiculous. However, since the metabolism is different in rats, they use a conversion factor of 6, so you divide the 5 milligram per kg, divide that by 6, and that kind of gives you 0.83 milligrams per kg, which is like 83 milligrams a day for 100 kg individual, so this was the largest dose used, and that is quite common for users because that would give you essentially 300 milligrams of Tren a week. So they also did a few cultures where they added Trenbolone to, like, cultures of neuronal tissue, and they added Trenbolone to see if it was apoptotic. They also wanted to test other enzymes. They didn't just look at amyloid beta, but mostly that is the result that's reported. So they did, so obviously this study would be quite difficult in humans because you'd have to administer the drug and then essentially do an autopsy to see if there was accumulation of amyloid beta, because they stain the brains afterwards. So the study did record that Trenbolone crosses the blood-brain barrier, which isn't surprising at all, because all androgens do, and not surprisingly, it had a predilection for the hippocampus. And some report this as a Tren-specific thing, but it's not, because the hippocampus has both androgen and estrogen receptors in it, so it is it is affected by any androgen, in fact, not just Tren. So yeah, it did accumulate in the hippocampus in the brain. They looked at the brain of the fetuses in the pregnant mice, female mice, and they found that it also accumulated in the fetus brain. So if you're pregnant, I would not advise using Tren because it could impact your fetus. So it essentially, they saw that there was a peak at 12 hours of this accumulation, and predominantly it was in the hippocampus when they the highest levels were recorded there. They also did serum and CSF levels, but I'll get onto that just now. So it accumulated even more so in muscle tissues, which isn't surprising since that's its main use, but I'm not sure of the use of amyloid in muscle tissue, so that was a bit of a weird stat. So the issue is, I'll show up the graphs, and this shows the dosage that was given and the peak level that was achieved in terms of your AB or amyloid beta 42 levels. So that's the level they were recording, and if you look, the CSF and female, the problem with the female rat results is they didn't reach significance, so the p-value must have been above 0.05, and that was mainly due to limited sample size. They didn't have many female rats. And as you see, it does accumulate in the brain, in the hippocampus. But you'll see over here, although they didn't reach significance, you'll notice that in the CSF and in the plasma of the female, it actually seemed to decrease. Now, there is a theory behind this. So I'll link another study, but even it's not significant, so we shouldn't really pay attention to those results. But this trend of a decreasing serum amyloid beta 42 is actually a theory, and it's highly speculative, but the theory states that if your amyloid beta levels are decreasing in your plasma, that means it's probably accumulating elsewhere, and they use this as a predictive value of individuals getting dementia, and more importantly, dementia secondary to Alzheimer's disease. And it seems that whilst this marker, they have shown that it also increases sometimes, but the most recent study shows that decreasing levels in the serum and CSF are not ideal if you're predicting chance of Alzheimer's. So other things, remember there were the cell cultures that had direct inoculation. The problem is it's difficult to replicate these in humans. But anyway, the cell viability was reduced when with Tren. It induced morphological changes to the actual neurons. So the chromatin network is like, or I'm probably getting this a bit wrong, but it's like where all the DNA clumps up together, and it's in the nucleus of the cell. And they saw there was condensation and fragmentation of this chromatin network in these cells, which is sometimes an early sign of apoptosis occurring. So apoptosis is like signal cell death, or what's a programmed cell death. So could possibly be toxic, although you're never getting direct Tren into your brain. It's always slightly altered when in serum, but it's interesting to note. So they also measured this enzyme called caspase 3. And now this is where people kind of pick and choose what they want to represent with the data. Because the caspase 3, it's not a great marker. I don't know why the study picked this marker, because it's fairly new and it doesn't have definitive links to neurodegeneration. However, Tren seem to increase its levels, which increases neurodegeneration essentially. But this was also an in vitro analysis. However, this is where people said if you add testosterone, it's protective. And they did find that testosterone was protective, and it did decrease the caspase 3 levels, and Tren increased that, and you want a lower level. So it could possibly help with Tren's deleterious effects there. However, that isn't very useful. It's not a great marker, because I've never seen it in other studies as a for predicting neurodegeneration and things, but it's a hypothesized that it might. So then they also measured this presenilin 1 level was also measured. Let me just focus it. So this is another hypothesis, but so this I'll just call it PS, but presenilin 1. And the reason they tested this is because a gene mutation to presenilin 1 has been shown in early onset Alzheimer's and familial Alzheimer's. So they wanted to see what happened here. And it's also assumed that this PS protein is important in learning, memory, neuronal survival, for the synapse between the different neurons, as well as regulation of neurotransmitters. And so whilst it's not all that was shown is that PS1 was downregulated. Testosterone seemed to, again, be protective of this. So we'll go on to the discussion. Then to start, the discussion was a bit trash. Oh, not trash, that's a bit harsh. But the discussion is essentially what I did with the results and trying to put them, analyzing them. But they just had these odd non-scientific, well, they're not really scientific phrases. I just wanted to critique it. But overall the study was fine, I think. There could possibly be a link with amyloid beta buildup in the brain, and assuming the amyloid hypothesis is true, that could lead to Alzheimer's disease. But we have no definitive proof. But yeah, this is what they mentioned in the discussion. They said 17 beta Trenbolone is if it's injected again, its concentrations in the brain and the hippocampus will even be exponentially increased. Well, they didn't test that, so they don't know. It may peak or, plateau. They can't just say something like that. You can't make an assertion without the evidence. They didn't link anything that would show it would increase further. And then they mentioned another thing where they were trying to prove that as we mentioned, that presilin 1 protein was decreased with Tren, and they said we can interpret PS1 decreasing as a mutation in the PS1 gene because you lose normal PS1, which is not true, because it's this mutation might just give you abnormal PS1, which has its own activity, which may increase amyloid beta buildup. They can't just make statements like these. So I would implore you to read it yourself and look at the results and skip the discussion if possible. It's a bit anyway. So, just like my closing thoughts is, there does appear to be this accumulation of amyloid beta 42. Sorry if I said alpha beta, and that it could contribute to the Alzheimer's, given that hypothesis is true, and it does cause apoptosis indirect inoculation. It does interfere with caspase-3 and P1 or PS1. The good news, well, this is reported you have to run tests with Tren. I would obviously advise that, but it doesn't protect you from amyloid beta buildup, because test hasn't been found to be protective for that, but it could help ameliorate its effects on caspase and PS1. And to get this effect, I looked at the doses they used, and they used a testosterone dose of 10 nanomolars or micromoles per liter, and as compared to 100. So it was one. So essentially, the Tren dose was 10 times more. So at a 10 times lower dose of test, you'll still have this protective effect. So this is just a harm reduction, I suppose, and I assume most people would use a better ratio than that anyway. But if your test is low, you still get those beneficial effects. My suggestion for a study would be to measure the plasma and CSF levels, amyloid beta 42 and 40 levels in Tren users, and compare it to Tren and test and things like that, because although you can't autopsy, these decreasing levels could indicate possible development of Alzheimer's. But thank you for watching this video. I know it's a bit long, and make your conclusion from that as you will. And yeah, I hope you enjoyed it, and if you did, like, comment, subscribe, and thank you. I will see you in the next video.